Hello, this is Paul from Tech. The last lecture we defined the limit at infinity, right? And we know how to guess or estimate the limits using a table list. And in this lecture, we're going to find the exact limit. Okay, so this is important. We will find the exact limit at infinity. Okay, the major result we're going to use is this one. Okay, we only have one theorem, and the theorem states in this: if r greater than 0 is a rational number, okay, but here is a rational number, then this limit equals 0. First, let me go to look at it. Is this the results meaningful? Yes. Why? Because this is intuitive. We think it just intuitive. And r is greater than 0, a number. You can imagine x raised to the r's power. The denominator goes to what? Goes to infinity, right? So 1 out of infinity, so one can imagine 1 out of infinity should be go down to 0. Okay, and if we don't going to prove this should be true intuitively, but how to exactly prove? Because later and a lot of examples going to use this theorem, so we need the proof. Okay, exactly. And of course, so first we look at it. This r is a rational number. Okay, we can write the rational number in this way, right? Mn are integers. Okay, and then so we look at it. We can directly find the limits. Go to few steps, and then the final result is 0. Just do calculation. Okay, and then, so the first step. Look at it. The first step, and the r is a rational exponent. Rational exponent we can write into this is a radical, right? So we can write the rational power into radical. So the radical is a nth radical, nth root, and then raised to the power of n. To remember, this is the definition. And if we write it in this way, and then another step is going to move the position of the limit by what? By the limit laws we learned before. Can you see? So first this is the base, and raised to the power, and we have what? We have power law. Okay, the limit can go into the base, right? And then we have a root law, so the limit can go into the root, okay, under the root. Therefore, finally we go into this way, right? We just use the limit law we learned, and now we have these results. Do you remember the last lecture? We exactly prove. And what is the limit 1 out of x? That's 0, right? Okay, therefore the result is 0, definitely. Okay, and a little bit more. Okay, so r is a rational, can be extended into any real number. In the future, we will going to introduce. Okay, r is any real number greater than 0. The results are still true, and the general result is just as this. We used this, right? It's 1 out of infinity, always 0. Okay, keep in mind 1 out of infinity. We always know it's 0. Let me show you a few examples. So the first example, and we need to find, okay, the limit, or if the limit does not exist, show the limit does not exist, or if the limit does not exist but the infinity, okay, so show the infinity. Okay, so how about this? So the first we look at this rational, right? A polynomial over polynomial. If we directly plug infinity to the bottom, infinity to the bottom, infinity to the top, what do we get? We get an infinity over infinity. So let me write, and this is what? Infinite over infinite. If someone like it, you can put that like this. Okay, because infinite is not a number. Okay, it's just a formula. So this is what this form. This form is same as similar as 0 over 0. We call it what? 0 over 0. We call it indeterminate form. It's called indeterminate form. Determinate form. Why is indeterminate. Let me show one example for you. And this is exactly indeterminate. We cannot determine just by the form. Okay, we need to look at the detail. Why? Can you see this? I give you two examples. The first example is this. If it's 2x over x, can you see? Is what? Infinity over infinity, right? This is infinity over infinity. Okay, because this is infinity, this goes to infinity. However, we know the result. Okay, because of what? And this x and this x are the same, right? So common factor we factored out, divided out. So 2, the limit of 2 is 2. See, the first we get it, the limit is 2. I give you another. And if I change 2 to 3, and everyone know this, cancel x, what do we get? We get 3. But this is also the form of infinity over infinity. See, both the form are the same, infinity over infinity, however the results are different, which means what? This is indeterminable. Okay, it's an indeterminate form. You have to look at the detail. And for these questions, we cannot factor out and then divide it out something. Okay, however, we have another way. So I will show you another way. Is to this divided. Let me write it down. And this type of form to find the limit, the major way are the same. Can you see? Is to this manipulate. Okay, manipulate this function by divided. Let me see. Write down. We need to divide the numerator and the denominator by x squared. Divided by x squared. Okay. Why we divided by x squared? So what is the x squared? X squared is what? Is the largest term in the bottom. This is the largest. Keep in mind always. This is the largest term in the denominator. In denominator, okay, we simply say. We always do this. Okay, manipulator. Find the largest term in the denominator, then divide it by the numerator and the denominator by the largest term in the denominator. Okay, and in this example, divided by x squared. See, what do we get? I will get this. Let me write. What do we get? We get x minus 2 divided by x squared. That's the top. The bottom x squared plus 1 divided by x squared. Okay, why divided? Because another step. See, the numerator is a fraction. We can expand this fraction. Expand. After expand, you will find something. Okay, well, we're going to do this. Expand all the fractions in the top and in the bottom. Okay, after we expand, see, we will get something. The limit x approaches infinity. So x over x squared is 1 out of x minus 2 over x squared. Can you see? And the original is 1 fraction. Now we have a 2. Why we wrote this? Do you remember? What the limit of this? 0. What the limit of 0? By the theorem. Okay, so that's the reason why we're going to divide it by the highest or the largest term, and why we need to expand. Okay, because we are going to use the theorem. So the bottom we expand x squared over x squared is 1, right? Plus 1 over x squared. Okay, now all we need to do is use the limit law. Okay, and the quotient law and the sum law and the difference law, whatever. And we use the limit law we learned before. The limit laws, and then this limit can go to the first, go to the second, go to the third, go to here is 1, and go to the fourth, which means after we use this limit, you know, the limit of the first is 0, this is 0, this is 0, and then you can use this, the limit law and the theorem we just discussed. Okay, see, 1 over x raised to the rth power and then what do we have? We will get this. So the limit we don't have, right? So we don't have limit. Now the limit goes to the top. This is 0. Goes to here is 0. Goes to here is 1. Goes to here is 0. Okay, all the 0 is from the theorem, and then do calculation is 0. That's the result. Okay, here's the first example, and then I have a few other examples to show you. Okay, keep in mind, so we have the basic idea is to this: manipulate the fractions by divided by, okay, the largest term in the denominator. Let me show you one more. So here is they are the same. Okay, so they are the similar. What are we going to do? It's a fraction. If we directly plug infinity, and this is infinity, so it's still infinity over infinity. Okay, so we still have this infinity over infinity. So the indeterminate, what are we going to do? Divided by the largest term, which is x, right? Okay, divided. Let me see. Divided by the y, the numerator denominator by the same, by x. Someone will say, why is not divided by 4x? 4 does not matter. Okay, so we only divided by x is good. After we divided by x, see what do we get? We will get this. We will get the limit x approaching infinity is here, and this is the big term. Let me write it this way: x plus 3x squared. This is the original, but divided by x, right? Okay, the bottom is 4x minus 1 divided by x. Okay, now what are we going to do? And we need to put this x inside the square root. Let me show you. And if we put a number inside the square root, we need to raise to the power of 2. Okay, and the opposite, if we take x squared out from the square root, we take 2 away. Can you imagine that? Okay, so which means divided by x, or divided by x, x go into is divided by x squared. Does that make sense? Divided by x squared in the square root. Okay, let me direct the root. Or we simply say now is just put this x in, put it into square root. Okay, put it into square root. See what do we have? We will have this. That's the limit x approaching infinite. Okay, so here is a big square root, and the x plus 3x squared, this is the original, is divided by what? Divided not by x. Okay, outside is x, so inside is x squared. You can imagine, okay, square root go to the top is the original, square root go to the bottom, square root of x squared, which is x. Okay, keep in mind that, don't make a mistake. X go inside goes to x squared. That's all. And of course, the bottom, let me write. I just copy it. 4x minus 1 over x. Okay. And then what do? We just expand. Okay, just expand. Expand the first. What do we get? Can you see this? I will get this way. I will get the limit x approaching infinity. I just expand. Okay, expand is a square root, right? So it's a square root. X over x squared is 1 over x plus 3x squared over x squared is 3. This gets much simple. Okay, so how about the bottom? So the bottom goes to this. 4x over x is go to 4, right? Okay, minus 1 out of over x. Okay, so this is just expand. Why we expand it? Because we going to use the theorem. 1 out of x approaches 0. 1 out of x approaches 0. Okay, and then what are we going to do? You can use the it's still the same. I'm going to use the limit law. Okay, use the limit laws and the theorem we discussed. Okay, and then what do we have? We directly have the results. So this is which means the limit go inside is square root of 0 plus 3, right? Is 4. The limit goes to here is minus 0. And the do calculations, so you will get a square root of 3 over 4. This is the result. The idea is still same, right? It's still similar. All you need to pay attention is a number going inside the square root that goes to square. Okay, so you need to put the raise to the square. Okay, raise to the second power. One more. Can we look at this question? Still the same idea. Okay, idea is the same. First, we look at the form, and the x approaching infinity, e raised to the x power imagine. Okay, goes to infinity. So the top is infinity. Okay, probably you say negative. Good. So let me put is negative infinity. Okay, so negative infinite is the top, right? What is the bottom? The bottom is infinite. Okay. Don't care about the negative. Infinite over infinite is already indeterminable. Okay, so this is indeterminate. So they are indeterminate. And then now what are we going to do? The same, right? The same idea. Divided the numerator denominator by the highest term in the bottom. Of course, it is e raised to the x power. E raised to the x power. You find this term divided, and then we will have the similar results. Easy to get it. Now, what do we do? Is the limit x approaches infinity. Okay, so can you see? And 1 minus e raised to the x is the top, divided by e raised to the x. And the bottom is 1 plus 2ex, and also divided by e raised to the x power. And then what to do? Expand, right? Okay, expand the fraction. Expand the fraction, then we can use the theorem. Okay, the fractions. What do we do? And then we will have this. Okay, we have the limit x approaches infinite. Okay, now 1 divided by this is what? I just wrote 1 over x raised to the x power, e raised to the x power. This over this is 1, right? So minus 1. 1 over this is still 1 over e raised to the x power. 2 times this over this is get 2. Okay, so now you need one more result, and the limit of the law is the same, right? The limit goes to here. The limit goes to here. What kind of? We need to know this is 1 over infinite. Okay, so let me show you here. It's 1 over infinite. We need to know this is 0. Okay, keep in mind this is just a kind of a form. If this means what? If the denominator goes to infinity, and then flip is going to 0. Okay, and then what's the result? And the result should be equal to here. And we go to fraction. This goes to 0, right? So this is 0 minus 1. This is 0 plus 2. We get a negative 1 out of 2. So this is the results we get. Okay, the results we get. So they are similar. All these 3 questions are very similar. The idea. But this question is different. Okay, what to do? So this time is not a fraction. It's what? It's just a minus. Okay. First, let us check the form. And if log x goes here is infinite, right? I say this is infinite. X goes to infinite. Okay. So keep in mind, and this is also indeterminate. Indeterminate. And why this is infinite minus infinity is also indeterminate. Let me give you an example. Okay. Okay, look at this. Oh, we take a limit when x goes to infinity. Can you see x plus 1? This goes to infinity, right? And then minus x. This x also goes to infinity. So what this is infinite minus infinite. Of course, The result is what? X minus S is always 1. 1, the limit of 1 is what? The limit of 1 is 1, right? That's always 1. The same. You can imagine. Okay, I just change X plus 2 minus X. And then we will get that the limit X approaches infinity 2. The limit of 2 is 2. This is also infinity minus infinity. Just give yourself an idea. Okay, infinite minus infinite, this formula, we cannot determine the results. We need to look at the detail. Okay, so this form we still call the indeterminate form. I'll show you a method how to do this. We made the square root. Okay, what are we going to do? Rationalize. Okay. Remember this? When we made a square form, rationalize. And here we know denominator, so we can rationalize the numerator. Okay, so we can do this. We can rationalize numerator. Okay, and we can rationalize numerator. Okay, so let me go into root. We're going to rationalize, which means what? I have to times the conjugate, right? So this is a little bit longer. Okay, and the original, let me put here again, x squared plus 1 minus x. That's the original. What are we going to do? We're going to times the conjugate. Remember the conjugate is what? Is plus x, right? Okay, still not long enough. Okay, plus x minus x equals to plus. This is the conjugate. So you times the conjugate to the bottom. Should be x squared plus 1 plus x. See, and these are the same. When we cancel, there's nothing, right? Okay, but now what we can do? We can simplify the numerator by the difference of squares. Okay, do you remember the difference of squares? The difference of squares. Okay, which means the sum times the difference is the square of the difference of squares. Okay, so square of this minus square of this. Square of the first, you know, is x squared plus 1, right? Let me write one more step, and it is. If we wrote one more step, right, by the difference of square, and this square is x squared plus 1 minus x squared. That's this square root of square. I take the square root of away, right? So this is the difference of square, and at the bottom I just copy. And x squared plus 1 plus x. Okay, of course the numerator we can simplify, right? Okay, this time, can you see, we will get something new. This time the top goes to 1, the bottom goes to something, but this time is good. Okay, why? The denominator goes to infinity. This is infinity plus infinity is what? Okay, a infinite number. Okay, infinite plus infinite, definitely that's infinite, right? There's no problem. Okay, so what do we get? We get here. We get this is a 1 over infinite. 1 over infinite, remember we have the result is 0, right? So that's the result, 0. Okay. And this is 1. And look at another one. So here, what is? Okay, so let's explore something. X squared, this x approaching negative infinity. No matter what, this goes to infinity. What is? Negative number goes to up the power is a negative, so this goes to negative infinity, right? Infinite plus a negative infinity, which is what? Which is infinite minus infinite. Do you remember we just said this is an indeterminate, right? Okay, this is the indeterminate. Indeterminate, but this time we cannot rationalize how to do. Okay, can you see x square? X square is common factor. You can factor out. Okay, so this way is just a trick. Okay, it's just do this. You factor out x square. Why we do this? Because later you will see if we factor out, see what do we get. We will get another form x approaching negative infinity. After the factor is x square, and 1 left plus 2 times x raised to the 5th power left. Okay, why this works? Why? Can you see? This is the product, right? If someone you say I use the product law, and the product law, okay, the limit goes to the first. Okay, someone say the first that goes to water is not a number divergence, but a divergence to positive infinity. How about the second? See, 1 is okay, so this number goes to negative infinity. Okay, so if we wrote here, I just use the form, okay, whatever. So we will get this. This goes to positive infinity. This goes to negative infinity. Sorry, put the negative. And this is times. You can imagine positive infinity times negative infinity. What do we get? What do we get? We get a negative infinite. We get a negative infinite. This is the result. Okay, of course, you know negative infinity is not a number. This means what? The limit does not exist. However, it diverges to negative infinity. Do you remember the questions at the beginning? If the limit does not exist but go to infinity, we have to write the infinity, right? Okay, we have the last questions to show. How about the sign? What is sign? Sign is what kind of you learned before, okay, in trigonometry. Sign is like a wave-like, okay, it goes up, goes down, goes up, goes down. We call it isolate, okay. So we call it isolate between -1 and 1, right? Okay. Then you look at the infinity. Can the function point to a fixed number? No, never, because it's oscillate. So what are we going to say? Because of the oscillation, so the limit does not exist. Rather a little bit more, because the sine function, okay, this is a oscillate, okay, between what? As between -1 and 1, right? Always like this. So if you look at the right tail, it never approach, never gets stable. So what? The limit does not exist. So does not exist of the limit. Okay, so this is the reason. That's all. Thank you.